to our Data Center Knowledge webcast, Critical Data Center Infrastructure Covering the Last Mile, sponsored by Raritan and Server Technology. If you have any technical difficulties during today's session, please press the Help widget on your player console to receive assistance in solving common issues. If at any time you are having audio difficulties or issues with the advancing of the slides, please hit your F5 key to refresh your webcast console. Today's web seminar is being recorded and will be available on demand for 12 months starting tomorrow. You will receive an email when it is ready. Please feel free to submit any questions you may have for our speakers in the Q&A widget. Our moderator today is Vladimir Galibov, Research Director, Cloud and Data Center. And with that, the floor is all yours, Vlad.
Thank you, Emily. Hi, everyone. Thank you so much for joining us. My name is Vlad Galibov. I'm joined by Sven and Calvin today to really go deep into the topic of how we can improve the reliability of data centers through the last mile of power infrastructure. And I wanted to really kind of start by highlighting a few of the key trends that, as analysts, my team and I see in the data center industry. Ultimately, I know that this is something that people look out from us. So let's take a look at the high level kind of trends. So first, at the outset, when people refer to the digital economy, it often comes across as something that will happen in the future. But hopefully the last few years, especially the COVID lockdown, has taught us that the world economy is a digital economy. 80 million servers in 8,000 data centers in many small locations power that digital economy. So data center reliability is now critical to economic success. So at the micro level, it is critical to business success. The analysts at Omdia are always looking at application level trends. And currently what they see is that AI tops the charts in terms of accelerated growth. Servers configured to run AI applications are particularly power hungry. I will show you an example in a moment, and are driving a new push for data center efficiency. I'd argue that being able to monitor power consumption and enact action based on that information has never been more important. Another trend that I'll show you later is based on data from our partner organization, AFCOM. It's an industry association of data center professionals, and every year we ask these guys about their biggest challenges. At the moment, staff and servicing costs are top items of concern. So more operators this year than last year highlighted that these two things, staffing and servicing, are having an impact on their OPEX. They're creating higher levels of operating expenditure. Therefore, automating, making the job of the data center operator easier is of increasing importance. And finally, of course, how could we not talk about latency? Latency is a key application performance determinant. It is driving edge deployments. And really, what we're hearing is that more and more computing are moving to the edge, closer to the IoT devices and users, closer to where the data is generated. This is creating a bigger than ever need to remotely manage and consistently monitor these devices. Today, we're going to talk about rack power distribution, and the thought that we wanted to kick off the discussion with is that ultimately power redundancy, reliability, and monitoring are only as good as the last mile of the critical infrastructure. So let's quickly have a bit of a deeper dive into some of the trends that I highlighted and exemplify them with actual data. Let's take a look at what the numbers are saying. So first, downtime is now business downtime. Data centers can't really go off. Most failures today result in at least $100,000 in revenue loss. So data center operators also tell us that over 80% of incidents stem from staff failing to follow procedures or procedures that were incorrectly set up themselves. So high reliability better visibility, diagnostics, and importantly, predictive operations have an increasing monetary value. What your rack PDU is able to do today actually has a significant impact on your potential revenue coming in. Now, looking at applications, here you see our forecast for servers split by application. So you end up seeing our penetration of AI forecast. Some of the servers are used for AI model training, and others are used for AI model inference. The training ones, like this DGX NVIDIA server on the left, are the most power hungry. Each of these has extremely high performance, and each one is very critical within the actual computation of an AI model. So rack power distribution needs to, one, enable a whole new norm of power density, and second, very high reliability and the ability to monitor that each of these machines is able to operate well. Because each of these machines has a critical role to play in computing a model training. I mentioned that data center operators who are members of AFCOM give us their thoughts every year. When it comes to increased OPEX, this year, service costs, staffing came on the top. Nearly 80% of the data center operators that answered AFCOM's State of the Data Center survey highlighted those two. And what we saw is that when it comes to staffing challenges, multi-skilled data center operators were the hardest to find. So predictive operations, data, and diagnostics are key to addressing these challenges, and as a result are becoming key to enabling a cost-effective data center and higher margins. While we had the attention of the data center operators who are members of AFCOM, and by the way, this includes Oracle, Johnson & Johnson, Bloomberg, many financial institutions and government agencies, we asked them about edge computing. They said that they will place computing and storage equipment at more and more edge locations. This is driven by a requirement to reach a close to 10 millisecond latency. So we asked them about their latency requirements, and 48% of the respondents to AFCOM's annual State of the Data Center survey indicated that 9.9 millisecond is the acceptable latency time. The average is what I've put here on the slide, is 13.1 millisecond, which is pretty close to 10. By comparison, a few years ago, when I look at 2017, when the concept of edge computing was first coming up, we really were looking at 12 milliseconds. So in essence, how distributed resources are has increased because realizing the value of edge computing means that you're able to really execute actions that otherwise could not be done through a central data center. One example is being able to provide motion control on IoT devices in smart factories. The required latency for motion control is 5 milliseconds. So clearly, this is reaffirmed by this survey. It will be critical that, apart from investing in the edge computing equipment, companies invest in intelligent equipment that can provide consistent monitoring and can provide ensure that the power quality across the edge locations is high. And I hope everyone kind of already expects this whenever they plan their edge locations, but power quality is a huge challenge outside of a controlled data center environment. So before I turn the mic to you, our attendees, for a very quick question, I want to quickly recap our top observations as we prepared for this and as we look at the data points. So downtime is business critical, and the best way to prevent and resolve it is with intelligent infrastructure that has high reliability and security credentials. Rack PDUs need to enable rack density, redundancy, and predictive operations through data and diagnostics. The further out the data center equipment is placed, the higher risk of poor or inconsistent power quality. And finally, whether in the data center or at the edge, monitoring, predictive analytics should now be a must, because to be honest, the staffing challenges that we see today are not going to go away. So I've talked for 10 minutes, so let's make sure that everyone is engaged and excited. And by the way, thank you for sending us your questions. I can already see that we have some questions from the audience, so thank you very much. Before we answer your questions at the end, I would like to ask you a question. So could you please select the answer that applies to you? Which of the following do you consider to be a top priority for you today? Is it A, improving data center power efficiency, B, predictive operations, eliminating downtime through better visibility and real-time data? Is it C, increasing compute density, D, increasing intelligence of data center so that you can do more with less people or resources? Or is it E, solving unique edge computing challenges such as a requirement for increasing power, monitoring, and access capabilities? So first, while we let the audience answer this question, we'll give you a couple of minutes. Calvin, Sven, first, hi, thank you so much for joining us. One of the things that I don't think that we can ignore today is a strive for data centers to be more sustainable. So can you tell us what role does at the last mile, the distribution of power at the rack level play in sustainability, and how can we use a technology like Rack PDU to improve sustainability? Maybe we can start with Sven and then pass it on to Calvin.
Sure. Hello, everyone. This is Sven speaking. I'm very happy to talk to all of you today. Regarding your question, so a simple answer to this is our energy metering capability in our new G4 PDU product series. And only if you can measure the total energy consumption inside the rack cabinet, or even the individual energy consumption for every single computer, you know how much CO2 emission your operations generate. And only what you can measure, you can improve. And this is really key in modern data centers, especially if new countries coming up with new legislations, which will put extra effort on the data center operators to really identify the day-by-day energy spendings and then try to optimize these spendings during the operations.
Yeah, I think that's a great point, Sven. There's no doubt that's a key element. Some of the other things I think that intelligent power distribution units, and today we're talking about our new PX4 and Pro 4X products, are identifying things like zombie servers. We all know that servers that aren't doing any useful work use about half the power consumption just sitting there idle, and you can identify that with an intelligent PDU. And then sustainability in general, we know, is a big issue, and we're doing things to minimize the power consumption of our PDUs, and also taking other steps that are really, in line with our customers' sustainability goals.
It's so interesting. When we just met with data center operators at Data Center World in Austin, a great event. We had over 2,000 data center operators there, and it was very fruitful. But one of the things that people always expect that we will talk about when we talk about sustainability is buying clean energy. But one of the messages that I was kind of consistently giving in my conversations with them is that actually you should try to reduce your energy consumption. So what you're talking here about is reducing energy consumption by figuring out if you have idle servers that maybe should have a different strategy, by figuring out, by having data from measurement so that you can implement change. In reality, sustainability with its definition is, let's figure out how to do things with less, rather than let's just buy clean energy or renewable energy credits and waste our money. Instead, you could actually start real change by monitoring and through visibility. So we've given people about 2 minutes, so let's take a look at the answers. So Surprise, surprise, improving data center power efficiency came at the top. That is something that, of course, we know is top of mind to many people. So I'm not surprised to see that it is top of mind to our audience as well. Predictive operations, eliminating downtime through better visibility and real-time data came second. Of course, this makes total sense, right? At the moment, especially Sven, you know, for us in Europe, the power of energy is, the cost of energy is so high that it's really impacting the bottom line. And of course, every time there is a downtime, we earlier said $100,000 in revenue potential loss. So do these answers, I guess, surprise you? Maybe Kevin, you can comment first.
Yeah, I think it's funny because they are close, and it would be what we would expect. I think that efficiency is getting more key. We understand that. Some of it is the cost of power, and some of it today is actually power availability. We've had customers that are telling us that they can't get more power from the grids they're on, and they've got to look at other solutions. And then, of course, eliminating downtime is key for everybody, right? There's absolutely no doubt that that's always a key goal. Sometimes even to the not taking efficiency into account. But yeah, I no real surprises there. I think that data makes a lot of sense.
Yeah, I can confirm this. And on the new generation 4 PDUs, we have also implemented features to deal with this sheer amount of data we can measure with the PDUs, because in the end, we don't want to overload the operators in the day-by-day job. So what we can do is we can implement intelligent filters, we can pre-compute the data, and we only send alerts and warnings out to the operators when it is really needed. And this is a difference compared to standard PDUs. Intelligence PDUs have to pre-compute such data in order to use them as a useful tool in daily operations.
So, Kevin, I think the second kind of piece, it's very related to what you're able to do with your new generation rack PDUs. So, why don't we kind of pass the ball to you, and maybe you can walk us through some of the features.
Absolutely. So one of the key goals, and Sven is referenced it a little bit, obviously, is continuous real-time monitoring. And we're going to do that with power information. And we're also going to do that with some new power quality metrics that are very unique to the industry today. But some of the other things, and we're not going to be able to cover everything that this product does or these product series does today, but is really some power diagnostics information. And again, it's tied to uptime, and it's tied to really making our customers' lives much easier. So I thought I would take a couple use case examples here and go through them. So one of the key ones is really the breaker trip detection. So any PDU that's rated 30 amps or above is required to have overcurrent protection devices or branch circuits within the device, and they're typically either fuses or breakers. When a branch circuit is tripped, in many cases, if there's not a review of the trip curves between that and the breaker upstream, whether it's an RPP or a busway system, in some cases, you can even get the upstream breaker to trip, which can be very dangerous because you may have issues with losing the whole PDU. But let's just say that the branch circuit's overloaded and the breaker trips, and you get an alert from the PDU that lets you know that that's happened. It can be a difficult situation, especially if it's remote or at a colo. But even in a data center, it deals with power. It requires smart hands. So typically somebody's got to go out to the cabinet. They've got to determine the branch circuit that actually failed. Typically what they would do is they would unplug everything from that branch circuit. Then they would re-trip the breaker, reset the breaker. Then they would start to plug in devices, and then they would understand which device or which outlet actually had the problem. And then they would have to deal with the problem. Well, with our new diagnostics today and in intelligent PDU like the Pro 4X and the PX4 that we're talking about, we can tell you it was outlet 12 Therefore, you know the device and you know what caused the problem. So you don't have to take all that time to figure out which outlet or which device was the problem, you know, instantly, and it shows right up on the interface or the GUI as part of your alerts of what's going on. So the idea would be that you can easily solve these problems, much more solved easily if it's a remote application or an edge application, Vlad, like you've been talking about, but really just save significant time with our customers in really working through this type of problem. So not only with our diagnostics and with these use cases, we know that these are common issues with our customers today, and something that we've identified as a way to really help our customers out. Secondarily, one of the other problems that's fairly common within the industry is looking at where I would like to install a new device. So I've got a new server. I need to know where to put it. You know, I really need three things. Ultimately, I certainly need to know that there's cooling available. I need to know that there's power available. And obviously, you need to look at use space as well. But that can be a very daunting or sometimes manual process. Also, it's key that though we can tell you the power consumption at a particular point in time, what's really important is looking, let's say, over the last year and understanding your absolute worst case of both temperature and power consumption. And with our new min-max feature, we can let our users know what the greatest power draw was in that cabinet over, let's say, a year's period of time, and what the worst temperature is. So if my max consumption or worst case is Black Friday or whatever happens to be, we can go back and we can look at that. And so now when you're installing that new device within the cabinet, you really have some assurance that not only at the individual point in time, but actually looking holistically over the last year, I'm very comfortable knowing that I do have cooling overhead and I do have power overhead to go ahead and install that new device. So again, a time saver, critical information, makes your lives easier, and really helps solve some of your day-to-day problems within the data center itself. So those are just a couple, and I'll go through another one. But I think key points in making our customers' lives a lot easier, and then ultimately making sure that we avoid downtime problems. So next, let's look at some of the other advanced diagnostics that we've got here. What's interesting about these is, again, it's unique. There's nobody that's doing this in industry. What's also unique is that we can automatically trigger these events based on certain things like the branch circuit breaker tripping. We can also look at it automatically for dips and swells. And then we can also look at it for current inrush, which I'll talk a little bit more about, which is still a problem today. And we'll talk about that in a little more details. But what's interesting, and it gets back to, I think, something Sven alluded to earlier, and kind of an old thing from the green grid, was you really can improve what you're monitoring, and whether that's power or power quality, or understanding if you've got a power problem, by capturing the waveform here, which is current and voltage, we can give you that type of data. What's amazing about it, it's continuous and real time. So if you suspect you have problems, you know, you don't need to go out and purchase a separate meter or do anything like that. We can give you that data instantly. And we can also, if you want to look at, say, the waveform at the in-feed of the PDU, you can manually capture that as well. And then, of course, this information is available on the GUI or as part of the API. So it's real-time data. The images are stored within the PDU. It's FIFO, kind of first in, first out. But this is key information and understanding I had a problem. What was the problem? And understanding it, because the harmonics are an issue with today's switch mode power supplies, but ultimately dips and swells are also a huge issue, and dips are one of the more common problems for power data center outages today, actually. So this is a great indicator of understanding what happened at a certain event, and being able to go back and look at the data as it happened real time. And again, there's nobody really in industry that's doing anything even close to this right now. So, and the fact that you can initiate it and or it captures automatically on events, so you know if there's a problem, it's already done the work for you, and you can go back and look at the events is really extremely key, I think, for our users. So if we look at the waveform capture, and this slide actually covers a couple different things. One is that as relays are turned on, and you're looking at things like current inrush, we also have a feature within our products where we want to make sure that when the relays are turned on, that we maximize the life of those relays. And fairly unique feature that I believe we've patented is that we will switch on the relays at the zero crossing, and that really limits the amount of power that the relays are seeing. It extends their life. It also makes it easier on all the components within the PDU itself. So we actually will do our switching at zero crossing, and we will also look at the current inrush as the PDU is started up and the relays are switched on. And that does a couple key things, really. One, understanding a current inrush problem, and if you've got one or not, and then how you manage it by the order and how you cycle on the relays is really key. And you were talking about the high density and the high wattage on the power supplies today, and that really all ties together as part of that functionality. Also, you could use it to understand maybe you don't have a current inrush problem, and whether you'd want to use a switch PDU or maybe not want to use a switch PDU. Those switch PDUs are used a lot of different ways for remote reboot, and then often switch PDUs are also used to turn off the unused outlets. So as people are doing work in the cabinet, they don't plug in things they shouldn't, or move things around, or cause other problems with the branch loading or the three-phase load balancing. So it's kind of a culmination of all those advanced features, technology that we've been doing for years that we're refining or tuning, and then all the power quality, all the waveform captures, and all these use cases that our customers have told us are problems within their data center, kind of rolled up uniquely into our new PDU solutions.
Before we go into the question, I actually have a question from one of our audience members that I thought this is a good time to ask you, Calvin, even though question and answer is later. And I'll just go back to your, it's related to the trip detection. Will the computation, the processing of the data regarding current per outlet, etc., be done in the PDU and then send alerts, or does that processing fall to the network and additional compute servers?
Well, it can. So we're looking at two different things really on the current. We're looking at the branch current, because you don't want to get close to the usually a 20 amp max rating on the branch. So we can alert before you would overload the branch. We can alert that you've had a branch current breaker fail. We could also look at the current overall for the overall capacity of the rack by monitoring at the infeed of the PDU as well. And we can do waveform captures there as well. And then the alerts and alarms trip all the way through our APIs. We have a standard REST-based API. We've also implemented the new Redfish API. We've got SNMP traps. And like Sven said, a lot of that's really configurable within the user as to, in general terms, what sensor diagnostics you're going to get alerts and alarms for.
So I hope that helped answer that question. And by all means, if you have any follow-up questions, keep them coming. We do have a lot of questions, so I'm going to move us on as quickly as possible. So we have a question for you before we move on, and that is, what are the biggest challenges that you face to become more sustainable? We hear that sustainability is important, which is why we ask. And you know, are some of those in relation to adhering to upcoming sustainability reporting requirements? So what are your biggest challenges? Are they monitoring and measuring tools? For example, data availability. Are you having some budget or investment constraints? Are you having an organizational issue or limitations? Or are there any other external limitations? This is a pretty simple question, or a pretty short question, I would say. So I will probably give you a little bit less time than before. So in the meantime, there's a very interesting question that I think we can ask you. It's from the audience. I'll let either Calvin or Sven volunteer if they want to take it. The question is there a management control that can manage the rack PDUs within a data center? And also, follow-up question, are you able to set policy for different power requirements?
Yeah, I think those are great questions. And so, you know, we understand that we're part of the data center ecosystem, and therefore we can integrate with our open APIs to any of the DSIM systems. We can integrate to building management systems, back of house. We can integrate with tools like Ignite, Splunk. We can, if there's trending or graphing tools like Tableau, any of those tools, really, we can manage the data. And some of our partners on the DSIM side have tools that allow the customer to automate things like firmware updates, and even configure the units as they come online within the tool itself. So we fit within that environment easily.
One more comment to this question. There's also a very comprehensive software development kit available for free to everyone. It's available on our website, and with the software development kit, it is possible to instrument all of our PDUs in a data center environment. Some of our DCAM partners are using the SDK to implement the protocols our PDUs are talking. And besides the standard SNMP protocol or the latest Redfish implementation, we have also an extremely powerful REST API implemented. And the SDK provides a lot of language bindings, including C, C++, or also scripting languages like Perl or Python or JavaScript. So I encourage all of you who are more interested in this instrumentation of our PDs, look on our website and download the SDK with a lot of examples how to utilize it.
If I can just add one thing, and highlight what Kevin, is very important of what you're saying for me is that open API. Being able to actually interoperate with an ecosystem is very important. Most people already have a DSIM or already have an opinion about how they want to manage their data center because it's not new. So having an open API is very important. The first thing that our analysts ask these days when it comes to a real life deployment is, can it integrate with ServiceNow? Can you look at it from a central IT management system? Can you raise tickets and monitor the solution of those tickets? So from that perspective, open APIs are an absolute must, and I know that not all vendors do that. So I think you've made a really good decision to do that. So if there's any follow-up questions, again, I remind you to bring them in. But let's take a look at the results to our survey. So we asked you, what are the biggest challenges that you face to become more sustainable and adhere to upcoming sustainability reporting requirements? And most people said that they're having either a budget or a monitoring and measurement issue. These are two of the most commonly commonly mentioned questions that we hear. I'm just going to comment on the limited budget and investment constraints for a second before I ask Calvin and Sven to comment on the other response. So one of the things that we try to kind of highlight is sustainability isn't necessarily, being sustainable isn't necessarily a cost. So what we identified earlier with Calvin and Sven is the idea of you can measure and change how you use your IT within your data center. So I think being able to optimize the power consumption of of servers when they're idle, being able to change when you compute different workloads to actually save money at peak times. These are some of the really kind of key strategies that are available. So to me, being sustainable is actually a saving, can be a saving program, a program of how to spend less on power because power is so expensive today. Calvin, Sven, can you please comment on the kind of monitoring and measurement tools? Does that surprise you? You know, is that something that you hear from people a lot, that they need, you know, kind of more data?
I don't think it's a surprise at all. I don't know what you think, Sven, but I mean, that was really the driver for a lot of the new metrics within the products that we're offering now.
Yeah, exactly. We spend a lot of effort to implement better monitoring and measurement features and tools into our PDU firmware stack. And so we clearly listen to our customers, what they needed when we specified the new G4 PDUs. And I think the result is very clear, and we have a lot of features available in this area.
So why don't we, as you have the mic, perhaps kind of ask you, Sven, to highlight a few more of the features that we haven't touched upon yet.
Sure. As I said earlier, Legrand and especially our PDUs, vendor brands, Server Technology and Raritan have always spent a lot of engineering efforts to implement advanced energy metering and monitoring features in our PDUs. And with the release of the new Generation 4 PDU product series, we have completely renewed our embedded energy measurement architecture. So we used to use 8 and 16-bit microcontroller technology in the older generation PDUs to perform energy metering. And this technology was already able to provide billing grade metering accuracy to our customers, but it was not very scalable. And we had to use multiple microcontrollers in larger PDU models. So that's why we decided to design the new Generation 4 metering architecture, which is now based on very modern ARM Cortex M4 microcontrollers, which can be sourced from multiple vendors today. And in combination with very precise 24-bit A to D converter chips, we were able to implement a very powerful and also scalable energy metering circuitry, which now provides very comprehensive and also billing-grade energy metering for up to 27 outlets with just one microcontroller. So in other words, even on the highest density, 54 outlet PDU models, only 2 of these chips are required to perform individual energy metering on all the 54 outlets. And our new in-house developed 3-phase embedded power supply also utilizes the new metering circuitry for 3-phase inlet metering, as well as for circuit breaker trip detection. The same firmware architecture is also used on both the inlet and outlet metering chips, which allows us to provide the same metering features on the AC inlets as well on all the PDU outlets. And important to mention is that we have qualified our new metering circuitry according to the IEC standard 62053, and we are now able to accomplish 0.5% energy metering accuracy on the PDU inlets as well as on all individual outlets. The picture below shows one of the new G4 relay boards with support for 27 outlets, which is one of the highest density designs you can find in the PDU market today. A 3-phase 54 outlet PDU model only requires 2 of these relay boards, and the 2 metering chips on these boards are able to provide in total over 740 electrical measurement data samples every second. That's why I mentioned earlier, it's also important to intelligently filter this data and only provide relevant data on demand. So now certainly the question comes up, what's the value of having all this data available? The first and obvious use case for inlet and especially also for outlet energy metering in PDUs is of course the precise calculation of how much electrical energy you are spending for all your individual servers in your data centers. So this can, for instance, be used to calculate the annual IT operations costs for every organization within your company. Or your customers may want to see an open calculation model when you charge them for hosting their IT equipment in your data center facility. So the good news from us is you can rely on the accuracy of the energy metering data provided by our PDUs. We do qualify and certify our energy metering circuitry in-house and also on demand by externally accredited certification houses. The third-party DCM software, like Calvin mentioned already earlier, is usually used to connect then the energy metering data over the longer time periods to create monthly or annual energy spending reports. And a good advantage of the new generation architecture is we have implemented the firmware of our metering chips in-house. And that's why we are not locked into a specific chip vendor anymore. And this allows us to mitigate supply risks in the future. In addition to the energy metering features, we have also integrated advanced power quality monitoring features. So all these features got implemented according to the IEC standard 61557. And the standard we have used covers power quality monitoring requirements for the supply side as well as for the demand side applications. But since our PDUs are primarily used in the data centers, we have focused our implementations efforts on the demand side power quality monitoring features. So now features like three-phase current imbalance, current harmonic distortion, neutral current, inrush current measurement, residual or leakage current measurement, circuit breaker trip forensics, this is what Calvin talked about earlier, and also current waveform capture and display is available on the new generation PDUs. So all this measurement data is available on the web user interface of the PDU. You can see power quality related information for all inlets and also for every individual outlet. Also the branches behind circuit breakers are getting measured individually. Warning and alarm thresholds can be defined for every measurement parameter. And if thresholds are reached, the PDU can send these alerts over various data protocols. And Calvin has already talked about the waveform capturing feature, which is another available tool to visually inspect the power quality on the inlets and also on the outlets. So here you can see the magnified web user interface section, which shows the available measurement parameters on the AC inlet side. In the interest of time, let me just focus on two potential use cases for the measurement data. The measurement of unbalanced current inside a three-phase power distribution system is a very important feature because the phase with the highest load, of course, physically defines the maximum required backup capacity of your three-phase UPS in your data center. And if the phases are not equally loaded on the UPS, its lifetime can be affected negatively. A typical rule of thumb for a three-phase AC distribution system in a data center says that the imbalance between the phases should not exceed more than 5%. Then another often used power quality measurement parameter is the crest factor, which is simply said it's the peak to average ratio of the AC current that flows in a conductor. And in an ideal scenario, if you have an ideal sine wave AC current flow, the crest factor is 1.41, or mathematically explained or expressed correctly, it's the root of 2. And any variation, smaller or bigger, identifies a harmonic distortion of the AC current sine wave. So AC current sine wave distortion usually comes from switched mode power supplies, which are not working normally anymore. Inside these power supplies, you can find big capacitors for the energy storage. And when these capacitors are getting older or getting exposed to hot ambient air for a too long time period, they are losing their storage capacity over time, which leads to an aging effect and eventually to a power supply failure. So in other words, this crest factor is a good indicator for IT loads with faulty power supplies, and you should then schedule a replacement service soon. We have also implemented another more advanced indicator for the same use case, which is called the current total harmonic distortion parameter, which is available as well. Usually very expensive measurement tools like tools from Siemens are able to measure crest factors or THDs only on individual load levels. And with our new PDUs, you're getting these very useful power quality indicators more or less for free. Yeah, here you can see a complete overview about all available electrical measurement parameters in our PDUs. It shows the parameter units, its availability on inlets or outlets, and the accuracy for each parameter, and also the relevant IEC standard behind it. So we have implemented an automated test suite to qualify our metering circuitry, and this test suite is available in different locations at Legrand to ensure the highest implementation standards across all of our engineering teams. And with this test suite, we are able to generate test reports similar to the reports from third-party certification labs. Our automatic test suite utilizes and instruments very expensive equipment. Here you see the highly accurate current and voltage reference source that we're using from the company Fluke. And on the right-hand side, you see a snapshot of our automatically generated test report for all the measurement parameters. And yeah, with this slide, I would like to finish this topic. Thank you.
Thank you, Sven. And look, we have been overwhelmed by questions. I do a lot of these, and I, to be honest, have not seen such an engaged audience for a while. So instead of wasting time with kind of recapping conclusions, I'd like to move straight into the Q&A. So I'll leave this conclusion on the page while I ask you some of the first questions. Now, if we don't get to all questions, we will answer all of them on email. So please do not worry. You will not be forgotten. Especially some people have multiple follow-up questions one after the other. So don't worry, we will absolutely answer yours. So let's start with question number 1. With overhead busway power distribution, the available fault currents are getting very high. The rack PDUs seem to have low rating of 5 to 10K AIC. What solutions do you have when fault currents are 25, I'm guessing KA at 208 or 120 volts?
Well, typically the KIC rating of the breakers that we use within our PDUs are 10 KIC. Mm-hmm. You also have to size the upstream breaker proportionally to the breakers within the PDU itself. In general terms, if somebody wanted a very high fault current for an overcurrent protector, then they would go from a breaker to a fuse, which has 100 KIC rating. But that's a very detailed and very long discussion that I don't think, Vlad, we're gonna be able to cover here.
So let me comment on this.
Sorry, go ahead, Sven.
Yeah, let me comment on this. Just one quick more comment. We have released 2 new products. There's the Pro 4X and the PX4. And the PX4 PDU platform is going to be the engineering to order platform. Whenever customers have this very specific request, they can meet with our sales engineers and also with our engineering in the end, with our product management, to specify their custom needs. And then instead of using standard circuit breakers, we would implement fuses or very specific breaker technology, which is available today.
Excellent.
Yeah, that's a great point. Roughly about half our revenue on the PDU side is a unique or somewhat custom solution for our customers. So that's a core competency for us to be able to design, get through agency, and build unique PDU solutions and do it within a pretty reasonable time frame.
So let's move on to, there's a few questions that have all kind of come related to monitoring. So I want to make sure that we are actively kind of addressing them. So in a room of, as a practical question, so in a room with 200 racks, dual PDUs per rack, trying to understand how this will impact the network if we're going to try and implement that extended monitoring. So what will be the impact? Is there a huge impact, basically, that monitoring load on the network? Because our attendee is concerned about, the impact that this could have on the network and also on the TACAX server.
Yeah. So first of all, in a classical environment, you have a central DCM software available, which nowadays constantly pulls data from all the distributed PDUs. And our PDUs would by default not send out any data on its own, right? Unless you have a DCM software which supports modern APIs. But in such a scenario, which just got described, you usually also have a dedicated infrastructure network in place, and the PDUs are usually connected to this dedicated infrastructure network. And such a network nowadays, it's at least 1 gigabit per second provided on every Ethernet link. And our PDUs are able to provide gigabit Ethernet connectivity. So from our point of view, bandwidth concerns are not there. And usually you should really design your infrastructure network so that you have gigabit connectivity available to all the PDUs. And only then you can really max out all the features on the latest generation PDUs. Of course, like I said earlier, there are a lot of filters available, and you will only get the data you're interested in once you have configured the right filters in every single PDU.
So Sven, just to recap, because one of the follow-up questions is how do we predict the right kind of network load? Is the suggestion to kind of actually analyze which are the data points that you care about and only to collect those?
Yes, that's the general way to do it. Don't really submit all the raw data to your DCAM system, because this will get overloaded if you would do it. And like I said earlier, there's so many data points you can measure with our PDU, but you really have to optimize it for your environment, for your facility. And this is where consulting comes in from both DCIM and also from us, the PDU vendor. And we can, of course, provide bandwidth information if we would simulate a certain behavior of a PDU. That really depends on the use case.
Okay. In terms of kind of data retrieval, so one of your advice was choose which data point to take. One question that we have, it's a follow-up question from the same attendee, is what about the frequency of when you kind of take the question? Do you take the data? Do you have any advice on whether people should have a continuous stream of data, or they should perhaps get data from the PDU every 15 minutes? Yeah. Is there sort of a time series planning that should be done?
Yeah. So for very accurate energy metering applications, it's extremely important that the PDU can constantly measure current and voltage and precisely calculate the power and the energy based on this data. But the PDU should also be able to buffer the results of this calculation over a certain time period. Our network controller is able to buffer this data for a certain amount of time, which allows a DCIM system to receive a chunk of measured data at once. So you're not losing metering accuracy if you only pull the PDU for after, let's say, 1 minute or so. And this is possible. You don't have to constantly stream all the measured data into a DCIM system, because the PDU is able to buffer the data.
And Sven, with that same feature, if there was a network interruption, you don't lose any data either, right?
Right, that's correct. And again, that really depends on the real implementation, on the DCIM system you have in place, on the type of protocol you're using. Classical protocols is SNMP version 3, but the more modern DCIM systems also support our REST API so that they can talk with our PDUs in a more sophisticated way and not rely on SNMP. We have also implemented the latest protocol, the Redfish protocol for REC PDUs. This also helps to optimize the communication between all the distributed PDUs and the central DCM software.
I guess one kind of topic I'm not surprised that has come up was around kind of remote monitoring features. So could you maybe kind of give us a very quick walkthrough? I understand that we don't have much time on how challenging it is, or how easy it would be, maybe is a better question, to in what data is available in terms of remote monitoring of devices that are connected to your rack PDUs. Is the kind of the remote, in terms of the data that you are able to get remote, is it exactly the same as you would have in the data center, I'm guessing? So you're still, some of the trip data use case that we saw, the breaker trip detection, I'm guessing that is available whether it's remote or whether it's in the data center, for example. So just curious on these features, is there a difference whether you're in the central data center or at the edge?
Yeah, that doesn't really matter. And I think you mentioned it earlier a little bit, Vlad, that what we're seeing is that whether it's a colo or a warehouse or whatever, typically you're going to have, in a lot of cases, more power quality challenges, let's say. In some of those applications, we see a lot international. And even in regular data centers today, you can't really be assured that there's two completely separate, power grids with delivering clean power. And so these continuous metrics that we're providing give our customers the ability to understand if they are having problems. Those problems often result in heating, they result in data loss, they result in server power supply failures, and they can do it with the devices they've got themselves. They don't need to go get a meter like that Fluke meter that Sven showed earlier and then try to install it in the cabinet and capture this information. It's all done within the PDU itself. It's all continuous. It's all in real time, and really can help them track down those types of problems with the devices, really no matter where the application is. Some of our customers also provide solutions to their customers, and when they get on site, in some cases, those solutions are in the data center or they may be in a different location. So they're very much concerned with the power quality because it's their racks or systems on another customer site, not necessarily in the data center. So if we look at cloud solutions and other things that are being provided remote, but still on site, this is a way to diagnose and really help with those problems as well. So it's kind of multifaceted, but it helps with those issues.
One more comment from my side on this. Every new modern PDU comes with a local LCD display where you can get the most critical information, especially if thresholds are exceeded for certain measurement points. But what you can also do is you can use an iPhone, iPad, or Android phone connected to the local USB interface of the PDU, and then you can get access to the web user interface over this mobile phone or over this tablet without having an IP connectivity available. And this is a great feature, especially for technicians which have to perform some work on site directly on the rack.
Well, thank you so much for this. And there's so many features that we didn't manage to get into. I had pre-warned the team here that we're going to be asking Calvin and Sven about stuff like cybersecurity, for example, and other features that they've added to this new generation of Rack Produce. But the best thing that I can suggest is you can see Sven and Calvin now. Hopefully, you're familiar with them because we've spent an hour together, and you can we will answer and follow up anything we haven't been able to get to on email. But by all means, stay in touch. And thank you so much for your attention. Thank you for your time, Sven and Calvin. And thank you for everyone for joining us. I hope that this is just the beginning of a continuous discussion. So have a lovely day, and thank you for your time again. Bye.
Thanks a lot. Bye-bye.
Thanks, Vlad.
Before we go, I'd like to once again thank Raritan and Server Technology for sponsoring today's event, as well as Vlad, Calvin, and Sven for the very informative discussion. Just a reminder, the seminar will be available on demand starting tomorrow, so please feel free to come back and review. Have a great day, and thank you for attending.